This video will review vertical angles and the vertical angle theorem. Let's start by defining what vertical angles are. Vertical angles are the angles that are opposite from each other, formed by the intersection of two lines. This is a relationship between pairs of angles. Again, pairs mean two angles. You cannot have one vertical angle and you cannot have three vertical angles. Vertical angles will all refer to two angles. Again, a pair of angles. Anytime two lines or two rays or two segments intersect, you form two pairs of vertical angles. In this case, these would be one of the pairs of vertical angles. Now, vertical angles does not always refer to the angles that are up and down. These would also be a pair of vertical angles. They're angles that are opposite from each other. Now, there's a special relationship about these angles. This is the vertical angle theorem. We abbreviate it like this. The vertical angle theorem says that any time two lines or segments intersect, the vertical angles are always equal to each other. Now, that means the pairs of angles. So up above, the angles that are blue, that pair of vertical angles would be equal to each other. And then the angles that are in the pink color would also be equal to each other. That does not mean that the blue angles and the pink angles have to be equal to each other also. They may or may not. All we can say is that each pair of vertical angles are equal. So in this case, if I have segments AC intersect with segment BD, I have two pairs of vertical angles. The ones that are AEB and CED, which are the ones that are up and down, would be congruent angles. The reason I know they're congruent angles would be, again, vertical angle theorem. That's my justification. But it's not the only pair of vertical angles. We also have the ones on the left and the right. The first pair, again, when we say angle AEB, from A to E to B would be referring to this one. When we say angle C to E to D, that's this one. But again, it's not the only pair of vertical angles. There's another pair. We have the pair on the left and the pair on the right. So we could also say that angle AED is congruent to angle BEC. So let me go ahead and write that. The measure of angle AED equals the measure of angle CEB. And again, it's vertical angle theorem. Now, sometimes instead of saying the measure of an angle is equal, we would also say that angles are congruent. So another way to write this would be angle AEB is congruent to angle CED. Measures of angles are equal, but the angles themselves are congruent. Measures mean the lengths, so lengths are equal. Congruent means the shape. They have the same size and shape. Now let's look at some examples that we can solve. I've got three quick problems up top. I'll do the first one for you. In number one, I see that we have two lines intersecting, or two segments intersecting in this case, and that angles X and 85 degrees are vertical angles. They're opposite from each other. So therefore I know, because they're vertical angles, that X equals 85 degrees. The justification, vertical angle theorem. Try the next two examples. All right, hopefully you said that for problem 2, it's doable. Some people look at this and forget that that box right there tells me that's a 90-degree angle. So then I know that X also equals 90 degrees because those are vertical angles again. Vertical angle theorem. And by the same logic, number 3, X equals 121 degrees because, again, vertical angle theorem. Now take a look at problem below. In this problem below, I've got three angles I need to solve for. I need to find how big the measure of angle A, B, and C are. Look at the relationships and see if you could apply vertical angle theorem to any of these. Well, angle A is not opposite in position from the 78-degree angle. Instead, angle B is. So I know that angle B, or the measure of angle B, is 78 degrees. Now, because we're not saying that this is angle BCA or something like that, I'm just going to say B equals 78 degrees. It's not really referring to angle B, it's just putting it in position B. And the reason I know that B equals 78 degrees is vertical angle theorem. However, angles A and C are also vertical angles, but I don't know either one. So I've got to find a different way to figure out what the measure of angles A or C are. Now, try to see if you can see a relationship to compare either angle A to that 78 degrees or angle C to the 78 degrees. All right, hopefully you came up with their linear pair. I know that angle A and the 78-degree angle form a straight angle, and they're adjacent. So if they are a linear pair, I know that either angle A plus 78 degrees add to be 180, or angle C plus the 78 degrees add to be 180. Now you could also do the same thing and say angles A and B are 180, or C or B are 180, but it's a little more work because we have to do some substitution. So instead, I'm just going to say that A plus 78 equals 180. When you do this, don't forget to justify. The way I know that's true is that they're a linear pair. You need to write that to get your credit. Subtracting, I see that the measure of angle A is 102 degrees. Now I've got to find angle C. See if you can come up with a way to do that. There's actually a couple different ways we could approach this. We could say that C is a linear pair with the 78, or C is a linear pair with B. However, it's going to be easier just to say that A and C are vertical angles. If A and C are vertical angles, they're equal, because of vertical angle theorem. Substituting what we know, A is 102 degrees, which means so is angle C. Angle C, therefore, is 102 degrees also. Alright, I hope this short video helped you understand vertical angles and the vertical angle theorem.